Hey everyone, so I wanted to make a video working out some word problems with trig just because uh, we might have, we have this second snow day, or technically third, and we might have a fourth one tomorrow. So I just wanted to go over or get into the new concept just a little bit and have this in video form. That way you can look over it. And I'm also going to be assigning a discussion post, just one simple question. I get it. These are snow days and you guys are home. And I don't want to make it too lengthy. But anyways, just want to review something from the video I made yesterday. This is a really important concept. So we have angle of depression and angle of elevation. So remember, for angle of elevation or angle of depression, just think about this. Like if you have your own viewpoint, and let's say this is your view, right? Angle of elevation is always going to be from the horizontal line that we're talking about going upwards. So that would be your angle of elevation. If you're, like let's say you're looking at a bird, right? This would be your angle of elevation. And if you're looking downwards, you take the horizontal line and you start from the horizontal line downwards. So your angle of elevation to, say, a piece of gum on the ground. This would be your angle of depression. So yeah, remember, elevation is from the horizontal line upwards to the point, and depression is from the horizontal line downwards to whatever your point is. So from here, we're going to do some word problems with no diagrams given. So this one says, Tariq wants to use a sheet of fiberboard 18 inches long to create a skateboard ramp with a height of 5.75 inches at its height's end. Find the angle of elevation made by the ramp with the ground. Round your answer to the nearest tenth of a degree. So obviously we're going to have the ground, and then we're going to have a ramp. And it's saying angle of elevation, right? From ramp to ground. So this is our horizontal line. So elevation is going to be right here. And then it says the ramp is going to have a height of 5.75 inches at its highest end. So this is going to be 5.75. And it says the sheet of fiberboard is going to be 18 inches long. So this is going to be 18. So now we just take what we have, and I'll write the guide one more time. SOHCAHTOA, or sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So from here, we look at what we have. We have opposite and hypotenuse. So we are given opposite and hypotenuse, and we're going to solve for theta. So from here, we take sine of theta is equal to 5.75 over 18. And remember, sine is you're inputting an angle and you're getting a ratio. So from here, we just know that we have to do inverse of sine. So and from here, we'll get our answer. And let's plug that in. Yeah, I had this one plugged in earlier. So inverse sine of 5.75 over 18 is 18.6 degrees. So angle of elevation is 18.6 degrees. Okay, number 2. Let me move these real quick. All right. It says Musa leans a 28-foot ladder against the wall. If the ladder reaches up 24.2 feet up the wall, what angle does it form with the ground? And this one is very similar to the one that we just did. So we have a ladder going against a wall. So that's, we'll say it's like right here. The ladder reaches 24.2 feet above the wall, or up the wall. So this is 24.2 feet. It says, what angle does it form with the ground? And so it also tells us the ladder is 28 feet. So we write down our given. We are given opposite and hypotenuse. And we are going to solve for theta. And it's saying what angle does it make with the ground, so theta is going to be right here. Not all problems are going to necessarily say elevation or depression, but it's going to ask you for the angle, and it's asking what angle it forms with the ground. So obviously from the ground up, it's going to be our theta. So this one, like the last one, sine theta is equal to 24.2 over 28. And then just like the last problem, it's inverse sine. That'll give us our angle. So our angle is 59.8 degrees. Okay. So working number 3. Says, from a hot air balloon, Adriel measures a 22-degree angle of depression to a landmark that is 743 feet away, measuring horizontally. What is the balloon's vertical distance above the ground? Round your answer to the nearest hundredth if necessary. So it says from a hot air balloon, right? So let's just say this is a hot air balloon. There's a 22-degree angle of depression. So that means that it's going to go from here to a point. And this is your horizontal line because we're thinking about the air balloon as your horizontal line. So that means that the angle of depression is going to be from the horizontal line downwards. So the angle is 22 degrees this way. And then it says the landmark is 743 feet away, measuring horizontally. Obviously, horizontally is this way. So this is 743. You can also think of it as two right triangles. Obviously, it's 743 down there too. So it's saying, what is the vertical distance above the ground? Above the ground is obviously going to be here. And we can, you see how we set up a right triangle instead of just thinking of it as it touching the ground right here. So anyways, we'll see, we're checking what we're given. We are given an angle, so we're given theta. And if this is since we made a right triangle, we are given the adjacent side, and we want this right here, which is the height. And clearly the height is the opposite side, so we're solving for the opposite side. So which one uses A and O? That's going to be tangent. So when we set this up, we have tangent of, not theta because we have theta, tangent of 22 degrees is equal to opposite, or we'll just put height here, over adjacent, which is 743. Like we did in class, do this over 1, and we'll have the butterfly method. So when you cross multiply, we have 1 times h is h, and tangent of 22 degrees times 743 is our answer. Let's plug that in real quick. So yeah, our answer is 300.19 feet. Okay, so I'm just going to work two more problems. So an electrician leans an extension ladder against the outside wall of a house so that it reaches a box 31 feet up. So we have a ladder, and we know that our height is 31 feet up, right? So call this 31 feet. Ladder, so say the ladder goes this way. Ladder makes a 78-degree angle with the ground. Find the length of the ladder. So we want the length of the ladder. Just label this L. So we're given theta and the opposite side. And so now we're going to solve for the hypotenuse. And that, we're just working this another one again with sine. So it's going to be sine of 78 degrees is equal to opposite, which is 31, over the length of the ladder. Cross multiply, and we get L times sine of 78 is equal to 31. So then from here, our answer is L is equal to 31 over sine of 78 degrees. And let's plug that in real quick. So 31 divided by sine of 78. So the length of the ladder is 31.7 feet. Okay. Then I saved a really complicated one for the end. Just it's a real difficult one. Probably give me some trouble if I just since it's been a while. So it says a boat is heading towards a lighthouse. So let's go ahead and draw that. So we have a boat, and it's heading towards a lighthouse where Jeremiah is watching. So draw a lighthouse. Oops. And yeah, so this is our lighthouse. And he's saying that the distance is 126 feet. And obviously, remember, this is our horizontal line right here. It says Jeremiah measures an angle of depression to the boat at point A to be 11 degrees. So let's draw a line from the boat to the lighthouse. He said the angle of depression. So we take the horizontal line and then we move downwards from the horizontal line. So we have 11 degrees this way. And this is point A, as it said. And now it says Jeremiah takes another measurement and finds the angle of depression to the boat, now at point B. So let's draw point B over here. And obviously this is not to scale. That's going to be 78 degrees. So 78 degrees, and remember it's going this way. It's going to touch the horizontal line. So it's saying find the distance from point A to point B. So what are we given? And we're thinking of two right triangles. And I'll draw the right triangles right now. So we're given this one right here. And then we're given this right triangle right here. So we're given theta in both circumstances. We know the height. We can use the height over here, 126 feet. So that would be the opposite for both right triangles. And now we just want to find this first length right here, the white dotted line up here, and then the blue dotted line, because that would be the distance A to B, right? Because in the context of these triangles, the length of this long triangle minus the length of this short triangle would give us A to B. So, like I said, looking at the triangle again, and I'm sorry, I wrote theta 2 times. You have the opposite side, and we're going to solve for the adjacent side on both triangles. So we have opposite and adjacent, so clearly we're going to use tangent here. So tangent for the first one is tangent of 11 degrees is equal to opposite, so 126 over your adjacent, which we don't have, so we'll call that A. And then we have tangent of 78 degrees is equal to opposite, which is 126 over your adjacent, and we'll call that point B. So using the butterfly method again, just put 1 over here, cross multiply, so we have A tangent of 11 degrees equal to 126. Over here we have B tangent of 78 degrees is equal to 126. So clearly just this worked out is going to be A is equal to 126 over tangent of 11, and B is equal to 126 over tangent of 78 degrees. So let's calculate both of these. So we take this answer, subtract it by this answer, and the distance from point A to point B is 621.4 feet. All right. I hope this video helps, and I will have a discussion post on Canvas uploaded within a few minutes. So thank you for your time.